Hello everyone, my name is Valeria Reyes. Welcome to the Chemistry Podcast, where we will be sharing with you some information about chemistry. We will center on the concentrations of solutions and going in deep with water as a vital source. And for this, we will be hearing the development of the topics from some students that know well about the topics since they have already studied about them and have acquired the ability to explain it. I will start with the introduction of the topics of the concentration of solutions. Concentration is a measure of the amount of solute in a specific amount of solution. And the ways to express it, the concentration of solution are the percentage, parts per million, and molarity. First is the percentage. The percentage in the case of solutions expresses the amount of solute per 100 units of solution. The percentage can be expressed in terms of mass, volume, or mass volume. The percentage of mass indicates the mass of a solution for every 100 units of mass of the solution. The calculation of this percentage consists of multiplying by 100 the fraction of the solid over the solution. And it is important to establish that the mass of the solution is the sum of the masses of the solute and the solvent. And the percentage in volume indicates the volume of solution for every 100 units of volume in the solution. As in the percentage of mass, the calculation consists of multiplying the fraction of the solute in the solution by 100.
Thank you, Valeria. Hi, my name is Andrea, and I will introduce you the rest of the calculations. I'm going to continue talking about the solution concentrations. The next one is mass volume percent concentration, which describes the mass of the solute in grams for 100 milliliters of solution. In the calculations, the unit of mass of the solute is gram, and the unit of the solution volume is milliliters. You divide grams of solute with millimeter of solution and then multiply it by 100. This mass volume percent is used widely in hospitals, pharmacies for the preparation of intravenous solutions and medicines. The next one is molarity, a concentration that states the number of moles of solute exactly in 1 liter of solution. It is written like this. You divide moles of solute over liters over solution. The molarity of solution can be calculated when we know the moles of solute and the volume of solute in liters. Finally, we have parts per million, ppm. It's a way to express the concentration of a solution that is used when the amount of solute in it is small or extremely diluted. To get it, you just divide amount of solute by the amount of solution and multiply it by 10 to the 6th power. And if you already know the percentage of the data, it's only multiplied by 10 to the 4th power.
Hi, I am Sophia. Now that we've finished the concentration section, I'll be guiding you through the topic of water distribution and purification. First, we ought to talk about water. What is it exactly? Water is the essential compound for life. The human body contains approximately 70% water at birth and 60% in adulthood. It is the essential substance in which the chemical reactions that allow life take place. Now that we know a little bit about water, we can talk about its distribution. Water is the most abundant natural resource in nature, 70% of the surface in Earth, and it is distributed in seas, oceans, rivers, lakes, and ponds. Calculations state there is 1.50 million kilometers cubed of water on the planet, 97% of that number being salt water and only 3% of fresh water, of which 2/3 are concentrated in polar ice caps, meaning 7.5 billions of beings depend on that 1% of fresh water. Moving on to water purification, it is the treatment water undergoes to make it potable, which we can summarize in 5 simple steps. First, we have filtration. In this step, we remove all kinds of relatively large objects, such as waste, branches, fish, etc. After this comes flocculation and sedimentation, where the tiny particles are trapped through the use of flocculants such as lime and alum, forming a gelatinous mass with the suspended particles and then precipitates them to the bottom. Right after this step comes fine filtration, which is the step that eliminates the remaining particles by passing the water through fine sand filters. Aeration is the step that follows. It basically consists of eliminating the dissolved gases remaining by putting the water in contact with the earth, utilizing sprinkling or bubbling. Finally, we move on to disinfection. So, to ensure the elimination of pathogenic bacteria, the water is disinfected by chlorine gas. In some countries, ozone is used. Now you're an expert on water distribution and purification.
Thanks a lot, Sophia, for your explanation. Now, I think it's time to share important information about the types of water to comprehend a little more about this topic. Hello, everyone. My name is Fatima, and I will be mentioning the different types in which water is divided. The water used for different human activities is mainly obtained from two natural sources: the surface water that comes from rivers, streams, and lagoons, and the subterranean water, that is the rainwater that filters through the ground, constituting what we call an aquifer. According to its containing salts of multiple ions, two types of water can be recognized: hard and soft. Water becomes hard when it has a higher than normal concentration of minerals, primarily calcium and magnesium. The water picks up these minerals from rocks and soil as it flows through the rivers. Soft water, on the other hand, has a low mineral content, either because it has not yet flowed through rocks or wells like the rainwater, or because the rocks it has come in contact with have little to no soluble minerals. Now, I will let you listen to the last but not least segment of this podcast.
Well, thank you, Fatima, for your clear explanation about the types of water. My name is Carla Cruz, and I have the task of explaining about water pollution that is affecting our environment in a drastic way. And if we do not stop this precious resource can come to an end. But what is water pollution? Water pollution occurs when harmful substances, often chemical or microorganisms, contaminate a stream, river, lake, ocean, aquifer, or other body of water, degrading water quality and rendering it toxic to humans or the environment. The most harmful contaminants are mercury, cadmium, lead, and arsenic minerals, because even in low concentrations they cause severe damage. However, there are some that in low concentrations are beneficial, but in excess can be very harmful, such as fluoride and iron, to mention a few. The concentration of pollutants depends on the region and the physicochemical methods used to transform water into potable water. We must know that what causes more pollution to water comes from anthropogenic origin, meaning that is caused by us, humans. Some examples are urban spills coming from domestic activities, industrial origin that varies depending on the industry, agricultural livestock that comes from pesticides and organic remains of animals which forms bacteria, and last but not least, maritime navigation, which is oil spills into the ocean, which harm severely to marine fauna, and it is difficult and almost impossible to regenerate these ecosystems. Within this, we can give a conclusion to this podcast. We hope that this information was useful, clear, and effective for you to use it and apply it in real life situations. Thank you so much for tuning in, and we hope you enjoy it.